Hey everybody, Dr. A here, and in this very short video, we are just going to give a quick overview of some background information on environmental loads. So what are environmental loads? Well, a quick description is the following. These are non-permanent loads acting on a structure caused by the environment. Okay, so what would that include? What are these non-permanent loads that could cause additional weight or forces on a structure that are caused by the environment? What would some of those be? So let's write some examples here. Obviously, some examples include rain, okay? When you have a rain event and that rain load maybe causes ponding or puddling on the roof of a structure, that's going to add additional load to the structure that it has to support. Similarly, ice, whenever you have ice freezing on a structural member or on a structural component or on an entire structure itself, it causes additional weight on the structure that it has to support. We also can include snow, flood loads, wind, earthquake, and tsunamis. Okay, and there are a few other environmental loads that could crop up. Some people look at wildfire loading as well. Wildfire loading is a little bit different. So if a structure is, you have a wildfire and a structure catches on fire due to that wildfire, it doesn't so much add extra weight to the structure. What it does is it degrades the material properties and the section properties of the structural elements. And because of that degradation, then the structure cannot support its dead load and live loads. So some people add in their wildfire loads. So let's look at each one of these real quickly. Okay, so rain loads, of course, that makes sense. You know, you have, let's say you have a building, okay, and you have these parapets here. And this is a section view of a building, and let's say it's raining. Okay, it's raining all around. This is my rain. And let's say that water starts to pond on your structure. Well, what's that going to do? That's going to tend to cause the roof to deflect and add that additional load on your roof structure due to the presence of water. So that's an example of rain. Let me show you an example of ice, okay? What about ice loading? Ice, let's say that you have a structural member like an I shape, okay? Or let's say you have like a structural rod, okay? And let's say you have a freezing event and you have a buildup of ice. Let's say you have a buildup of ice that freezes around an exposed beam, or you have a buildup of ice that freezes around a rod structure like I've shown here. Okay, well, that ice has weight. So it adds weight to a structural component that it is frozen around. Snow, same idea with snow. So instead of drawing a diagram, I'll say similar. I'll go ahead and draw a diagram, I guess, for us. Similar to rain. You know, let's say that, you know, maybe we have a building with a parapet again, and you know, you've got a snow event, and let's say that the snow piles up, and you know, the wind can blow the snow too, so you can have snow that piles up maybe due to wind. So you have color coordinate, you have snow maybe piling up with a greater intensity near your parapets right here. So that would be snow. We sometimes call that snow drift. So that would be snow adding more weight to your structure. Flood. What about flood? So if you have flood loads, let's say you're in a region where you get a lot of rainfall. So we're distinguishing flood from rain. So let's say that you live somewhere either near a body of water or just somewhere that just gets a lot of rain. Okay, and what can happen is you could have a buildup of water, right? So you have water here building up, and that water adds additional pressure to the side of a structure, and it tends to want to cause a lateral load in the structure and cause damage to it, cause it to deform. So flood loadings can be a problem, especially in coastal regions. Okay. We also have wind, earthquake, and tsunami. So wind is an obvious one, right? So if you have a wind load, you could have a structure here, and whenever you have high winds, that's going to place loading on your structure, and usually you have a windward and a leeward side. I was mixing up the first letters of that. So windward, when you have a windward wind blowing, that's the wind blowing in a particular direction and hitting your structure. And then on the leeward side, leeward wind loading can actually cause a suction effect. So this could be leeward side of your building here, but either way, that's going to tend to cause that structure to be exposed to additional loading. And then of course earthquake loading, abbreviate that EQ. Earthquake loading, let's say you got a structure here and the ground starts shaking. Okay, so let's say your ground starts shaking with a certain velocity or acceleration. Well, of course, these vibrations are going to travel all the way up your structural member and your structure itself and all of its members and cause damage. And then tsunami, I won't draw a picture of that one. Tsunami would be, like a combination of both wind and water, extreme force winds and water causing damage to a structure. So these are just a quick overview of different types of environmental loads. And so depending on what part of the country you're in or what university you go to, different universities, different professors in structural engineering in different parts of the country may emphasize some of these loadings more than others. So for example, if you're in the Arkansas, Illinois, or Tennessee area, West Tennessee area, you may focus more, learn more about earthquake loading and have to worry about that more since that region of the country is near a major fault, the New Madrid Fault. If you're in Florida or you're on the coast somewhere, Louisiana, California, you may be very worried about flood loading. California is also worried about earthquake loading. If you go more up north, you may be more concerned with ice and snow. So either way, you need to be aware of all of these because most regions experience at least a little bit of multiple of these types of environmental loads. But again, depending on where you are in the country or the world, you may need to worry about one or two of these more than the others. So, but as far as, structural engineering, structural analysis, it's good to be at least somewhat aware of all of them. So that's going to conclude this brief introductory video on environmental loads. Thanks for watching.